Hello and welcome to our installment of how to label and maneuver the icons and properly reference things in the Keynote template that you downloaded from Full Sail Online for your knowledge check activities. To get started, you basically download the template and it will download from FSO onto your downloads folder on your laptop. And when you open the file, this is generally what you'll get. I put my picture here so that you guys will know who's talking to you. I'm Mr. Johnson, and I'm one of the teachers here for Fundamentals of Physical Science. And we're going to do a brief instructional video on how to put the icons on your diagrams for your weekly activities. And I'll show you some of the best practices that I have told to my students, which are giving them really good grades on these activities. The first thing I like to do is I like to duplicate these symbols. So I will grab one and I'll just do Command C, and then I'll kind of want to paste it later. And I'll have an additional one, so it makes it easier to grade because I'll automatically know what a blue arrow means when I look over here in the legend. In these diagrams, you have to remember to always use a citation for the photograph that you want to place. And you have to always remember to follow the instructions by labeling the objects in your picture that conform or that are encircled or indicated by arrows. Okay, so in this case, this diagram probably won't match the picture that I have, but we'll just play with it accordingly. Let's say, for instance, we grab a picture off the desktop of an eagle. Okay, now here, sometimes the picture that you get might not fit in the box. And when you try to maneuver it, it'll keep the scale and keep the dimensions. So you can never really maneuver it the way you need to. So what you do is, in that case, you want to unconstrain the proportions. That way you can stretch it horizontally and vertically as you see fit so that you can fit it in the box, which isn't really all that important to do, but in case you wanted to liberate the format, you could, so that you could cover more of the screen. In order to start making modifications, you use the paintbrush icon here under Arrange, and automatically when you start maneuvering through, it will find things for you to manipulate. So Keynote understands shapes from pictures and texts. So I will continue to duplicate my icons. That way, when your instructor is grading stuff, they can see what exactly the green one means, because in certain other instances, we may have other weeks where we may have a yellow arrow, a blue arrow, and a purple arrow. And the purple arrow on week 2's diagram may not be the same case as purple arrow on week 3's diagram. So when things start to run together, even though we should know these diagrams by heart as instructors, we're human. And sometimes we forget that the purple arrow this week means gravity instead of force on the floating object in the water. So we will continue. After we're done duplicating things, we will show you how to manipulate them and rotate them and all the things that you want to do. Now, when we start talking about forces and things of that nature, we will need to make sure that the arrows themselves are used as vectors. These arrows are not being used to point out places on the diagram specifically that we're talking about. What they're used for are to label certain things on the diagram. So if we wanted to say, for instance, this eagle has a horizontal velocity, okay, first of all, we maneuver the arrow to where we could get it, and then we would arrange it so that it would be brought to the front. Okay. And so we can see that these icons here allow you to put things forward and backwards. So we'll assume that this is a horizontal velocity. You have to make sure that when we speak horizontally, it's parallel to the base of the diagram and it's going strictly left or right. And we see that this eagle is diving. So what we would want to do is make a vertical velocity. He's not only traveling left to right, he's traveling top to bottom. So he's moving, he's descending. So what if you wanted to rotate this arrow? There's a little dial here, a little knob that you can use to rotate. And we will rotate it down to 270, which is negative 90. And we would put the arrow indicating that the bird is traveling here. So try very hard not to cover your citation. So you could kind of shrink this thing here. You just grab one of the corners and hold it down and drag it. You can resize it. So you pinch it, hold it, and then maneuver it with the touchpad. And now we have two velocities. Now I know this diagram is talking about buoyancy and things of that nature. So we can also maneuver this too and pretend that there's a body of water here. Okay, so the first object that we would circle would be the object with a density greater than water, an object with density less than water, and so on and so forth. Let's assume that we had a lake here, and we take an object with a density greater than water. Well, there's nothing pictured here, right? But that still doesn't mean it's not valid. So we could just put a little circle down here, and we can say that this red object or this red circle is a rock, and the rock is submerged back in the background at a depth undisclosed someplace, and you label it something with a density greater than water is a rock. So that's it. It doesn't have to be pictured for it to exist. So lower than the density of water would be the eagle. Since he's touching the water, okay, this would be the area where he would feel his feet touch the water. And I'll bring this one forward. And you can adjust these things accordingly. And we're pretending that there's a body of water here and we're aligning the forces. Okay. Force of the floating object of the water would be here. And then force of the water on the floating object. You know, we're maneuvering this because we're going to align this better and actually make it so that it matches what we're doing. So we'll assume that the water is pushing up, okay, and his feet are bearing down. You don't necessarily have to put them directly at his feet. We don't have to be that accurate. You just know that a downward force is there and an upward force is there. And then we circle the eagle itself. A little circle on this guy. And we just maneuver things by dragging and dropping. And that's basically it. When I gave you the example of horizontal and vertical velocities, the arrows are not meant to point out that the velocities are acting at a given point. You need to show the direction that the eagle is going, down and to the right. So It's not you wouldn't, for instance, just say, hey, his horizontal velocity, hey, I'm pointing it out, so I know his horizontal velocity is from left to right. So I'm going to use this arrow and say, hey, his horizontal velocity is right there. It's right here. It's right at his chest. No, no, no. What you've done is you said that that's his vertical velocity and it's descending, and you didn't even label the horizontal velocity. So make sure that when you do velocities and trajectory problems, you do the arrows are pointing out or aligned with the direction of the velocity. In this case, we're talking about buoyancy, so we're on a whole nother subject. So what we're doing here is we're aligning the forces. He's adding pressure down on the water and upward out of the water as the water's reacting to him due to Newton's third law. The bird itself has less density because when the bird lands on the water, it will probably float. There's a rock or some submerged debris or a piece of iron or anything under the water. There are fish. There's dirt and sediment and vegetation that's buried under there. You can just label it. Okay, you just pick something, even though it may not be visible. Just use the labels anyway. And then the area over which the pressure is acting, and we try to constrain everything to the diagram accordingly. And with that said, that's the way you maneuver things. So this little paintbrush icon here is where you go, and then you can move things forward and backwards depending on your version of Keynote. I have a little older version. And then you can also maneuver and rotate objects. So make sure that you put things to the front accordingly, and you rotate them the way you see fit. And right here in the paintbrush icon, when you grab things, it will automatically give you the appropriate manipulative based on the icon or item that you selected. One trick that I like to use is that I like to tell my students to use Command Shift 4, Command Shift 4 keyboard shortcut, and take a screenshot of your diagram. You do not have to include a picture, but this is what I did so you can see me. And then we can go and we can go on to FSO. And once we go into FSO, we can log in, and you can cut and paste your screenshot if you'd like into the comment section for a given question. So let's take a look at this. Now that we're logged into FSO, you can either upload by dragging and dropping a PDF file that you saved, which is perfect. We can click it, go onto the Asset Hub, and look at it. Also, if you're having problems uploading, sometimes students have trouble uploading large files, so you could probably drag and drop your diagram into the actual conversation box, okay, for that particular question. Click here, and we drag and drop this screenshot here of our diagram. You know, it uploads it. Or you can just cut and you should be able to just copy and paste this thing onto FSO. And it should allow you to, as a comment, you should be able to do a cut and paste maneuver and actually put the document into the screen directly. That's one way you can do it. The other way you can do it is simply upload a file by selecting files. And other ways you can do it is simply place it here. And tonight FSO is very slow. So those are just some tips that we can use to get by on. And that concludes our presentation. So best of luck. And if you have any questions, make sure you contact your professor for the particulars that they want for their specific classes. And have a wonderful tour of Fundamentals of Physical Science.